and we're going to move on to our last talk of this session, which is going to be Mission Control Structure and Strategies, Lessons from the CanMoon Lunar Sample Return Analog Mission by Osinski et al.
Right, well, good morning, and thanks for having me here today. There we go, perfect. So yeah, thanks for having me. It's been great to hear and see some familiar faces. So I'm going to talk today about one of the number of analog missions that we've been conducting, and this is CanMoon. While this was a robotic sample return focused analog mission, I hope that many of the lessons learned, in particular for architecture and infrastructure that we'll be discussing this afternoon, will be relevant. So next slide, please. Just quickly before I continue, in addition to those authors on the front page, I'd just like to acknowledge the approximately 60 or so folks who are participating in the CanMoon mission operations, predominantly PhD students, postdocs, master's students, and some undergrads too, as well as a number of faculty. Next slide, please. So we've been conducting a number of analog missions, and I'll throw in a few little tidbits from some of these throughout, but focusing on CanMoon. We've been going to a variety of predominantly impact crater sites in Canada and volcanic sites too. And one that I won't talk about today that's down the bottom right was a Mars sample return focused analog missions carried out over a couple of years in Utah. And actually, a lot of our thinking and coming into the CanMoon expedition was based on the lessons learned from, Mars-focused mission operations, which of course are quite different, as we were hearing about yesterday. Next slide, please. So I definitely don't expect you to read everything on this slide, and neither am I. But suffice to say that we set this up with a series of scientific objectives, and really, one of our mantras has been throughout putting together analog missions is to make these science-driven. It's only by conducting, real science, rigorous science, such as Darlene was talking about, that ends up getting published in journals. But I think the mission operations lessons learned are relevant. And so just like with an actual mission, none of those people that were in mission control had any prior knowledge of the field site. We set out a number of operational objectives too, and you can see those there. One of the big things that we wanted to look at was the mission control operations structure for basically, 24/7 real-time lunar operations, looking at sample selection, testing the efficiency of remote science operations, including pre-planned strategic traverses. We did look at machine learning approaches and automated data analysis that we've been using a lot for Mars ops and here for the Moon, and then looking at and testing out virtual reality, having some segments of the mission control team use it and some not. Next slide, please. So just like an actual mission, we really started, big picture. We put in a lot of effort into just using remote sensing imagery to document the site. And if you missed it on a previous slide, the site here was Lanzarote in Spain, which is actually where one of the earlier speakers was talking about, because the Pangaea activity also occurs on this island. So that on the right-hand side there, you'll see a geological map created by the mission control team, again, without any prior knowledge. They knew where Lanzarote was, and they knew it was largely volcanic, but beyond that, that was about it. Next slide, please. We then actually held a series of workshops where the team, identified sites and regions of interest and planned out a number of strategic traverses that we kind of watched and kept track of in some detail as we went through. Next slide, please. Okay, so in terms of the mission control structure that's perhaps most relevant for this afternoon, we have the science team split into tactical and interpretation teams, led by an overall science lead. The tactical science team consisted of the instrument leads, GIS and localization, an image autonomy specialist specialized in machine learning, and of course a documentarian to keep track of everything. And this was a team, that did the initial QC processing, determining command sequences to upload and uplink to the rover. We found that when this team was not occupied with tactical activities, the tactical team then joined the interpretation team's activities. So that science interpretation team had its own manager. It worked independent of the tactical activities. was interpreting the data and doing some more long-range planning. I'll get to this role in a second, but they were coordinated by this science interpretation manager. Next slide, please. So quickly, the planning team, as you might expect, was responsible for the short and long-term planning of the rover activities on requests from the science processing team, uploading commands to the rover, and monitoring the traverse path and overall data management. We actually had GS and kind of localization people in both of these teams, so we can chat more this afternoon about how that worked out. So next slide, please. Just quickly, we didn't do 24/7 shifts, partly because it gets dark in Lanzarote, but we did have 2 shifts, and this was one of the things that we wanted to look at. It actually worked out quite well, given the field team was a few hours ahead, and so we had 1 shift starting at 3:45 a.m. Eastern, going to 9:15, with a 30-minute overlap. And one of the things we wanted to look at and test was the optimal shift handover. And so we started with 30 minutes, we played around with that a bit, and then we looked at kind of 2 different types of shift handoff, essentially the in-person and then, a virtual with documents only. So next slide, please. Just quickly, super quickly, to give you just a perspective of, the site and the terrain we were working on. And you can actually click on that link if you have access to the slides to see some more kind of panoramic images of the site. So volcanic terrain, very young volcanics in Lanzarote. Next slide, please. This is a bit of a zoom in on one of the traverses, the initial traverse at our second week's landing site. And I'll just kind of zoom into the dock location at the end there. And next slide, please. Just to give you a bit of an idea of the type of information that we had. You'll see kind of supercam-like spots, RMI, remote microimager spots, identifying features of interest. And in case you're wondering, the team was successful in meeting a lot of the science objectives because this particular rock is chock full of mantle xenoliths. And so this was really exciting and interesting for the science team. Next slide, please, to get into some lessons learned. So actually, Darlene mentioned this, and it's funny, I was looking at an image of our mission control structure, and we had kind of modular, more spread out and round table types of structures as opposed to in rows. And so, this is, it seemed like a simple thing, but I think testing out how you structure physically the mission control room is going to be quite interesting. We did find that the open concept did enable greater communication and ease of movement, or even physical movement, within the teams, which did increase efficiency. We did have the planning and science teams in different rooms, and I think that made those individual science teams more efficient, but it did present challenges for clear and efficient communication. So next slide, please. Should just add a bit more text. And so one of the things we found out, we actually added this role very early on, not really knowing how critical it would end up being, but the science and planning integrator role. And we found that, very quickly that this person became absolutely critical for efficient and real-time communications between the planning, tactical, and then the different science teams. Everything from getting vital information on traverse planning, keeping track of analyses, and then the long-term planning. We actually modeled this because we had people on the team involved in the roast activities that some of you may be familiar with in the lead up to Mars 2020, and that was the science engineering lead that we called it in the roast activities. So we did find this to be a really quite critical piece of the architecture. Next slide, please. Just a few more lessons learned. We did, collect metrics. We did find that the in-person shift handovers were slightly more efficient, but actually, both shift handovers did work quite well. If we had, very thorough shift handover documents, completed actually during the shifts, not left to the end, rich in annotated figures. We did find a major drawback was in the data management and visualization, but there's a lot of work going into that by various different groups, so hopefully we'll have that available to us. Something that I'll just do a shout out to that we looked at too is the value of robotic precursor missions in advance of human surface missions. We found the use of VR definitely enhances situational awareness, and there's still a role that I think was picked up in some of the comments earlier about the role for machine learning and automated data analysis. And I have 2 seconds to just move on to the next slide, which is the end. So thank you.
Thank you very much. Perfect timing.